Ok.
Go ahead.
Hola, hola, saludos, bienvenidos a este Zoom que vamos a tener ahora. Está a cargo de Adam Ahmed, que es el CEO de la compañía, y también tenemos a Ed Roland, desde la parte, ahora sí, tecnológica de la compañía.
Okay, so
Continue.
yes, so like I said, when we realize how new this technology, 3D technology has been around for a while, but the 3D concrete printing technology, hasn't really been around that long in terms of, like I said, just 7 years ago, 2016, it was the very first commercial building printed in Dubai. Dubai likes to be the first in everything. So they printed the first commercial building, which is the Dubai, Foundation Academy. So we believe that many companies have tried to create these robots, and Ed will explain more about this, but nobody's done it in a way where it could be scalable, meaning it can go mainstream. So back to you, Ali.
Ok, bueno, como pueden saber, bueno, Dubái, que es de los pioneros de hacer muchas cosas innovadoras, tiene una construcción que ha sido pues la inicial, el parteaguas de toda esta parte de la robótica, y obviamente en el mundo pues hay más robots y se está cada vez conociendo más este mercado y tendrá pues liderazgo este tema de la construcción por medio de robots. Así que en los próximos años podemos ver que este negocio de la construcción, pues por medio de los robots, es muy lucrativa. ¿Por qué? Porque nuestros robots son más escalables y ahorita lo vamos a ver.
Okay, there were many reasons why, most of the companies, they haven't really been able to sell these robots or build thousands of houses. The biggest project up to now is recently in America, 200 houses, and Ed will explain a bit more about that. So no company has been able to build thousands of houses, and we just, like I said, have got the robots ready. They've been fully tested, and we're going to be one of the first companies to build thousands of houses, in many different countries.
Ok, y bueno, una parte muy importante es que las máquinas que existen actualmente robóticas no tienen la capacidad de construir vamos a decir, a grande escala, donde pueden construir muchas casas, ¿no? Podrán construir 1, 2, 3, así, pero vamos a decir un fraccionamiento donde hay muchas casas, de una construcción de 10,000 casas, 20,000 casas, no existe un robot que tenga esa capacidad para fabricarlas. Actualmente hay nada más en América una compañía que pudo hacer 200 casas, pero realmente fue mucho tiempo el que se llevaron, a pesar de que era más rápido, pero se llevaron más tiempo. Entonces, esto que vamos a presentar, este producto que nosotros tenemos, que es escalable, que tiene la capacidad de imprimir demasiadas casas, ahora sí, por tiempo, esto va a ser pues bastante fuerte.
Okay, Ed, if you'd be kind enough now to go into a little bit more detail, what has stopped 3D concrete printing companies scaling, meaning being able to build affordable houses, and why is it that what you and your team have put together is the ultimate solution?
Yeah, okay. Go ahead.
Ok, bueno, y bueno, ahorita vamos a ver que nosotros, bueno, vamos a traer una solución para el mercado en todo este tema de la construcción.
Okay.
Ed, are you in a position to switch your camera on at all?
Sure. I'm just, I don't know. I'm kind of like, I've got the light behind me. I'm sitting
Sure.
I don't know if
No problem,
Yeah.
no problem. As long as they can see you, that's the main thing. Okay.
I look like I'm out of whatever.
You look darker than me, Ed, in this.
Yeah, I know. Yeah, I look like I'm in a mafia movie or something. Yeah. Yeah.
Okay.
Well, basically, 3DCP is very, very young. It's only been around 10 years or so. Really, anything going on in the whole business has only really been happening in the last 5 or 6 years. Most of the companies are interested in building their robots, making their technology better and everything, but they're not really interested in any kind of building regulations, building codes, and all of that. So I actually, with a lot of other people, set up a committee to write the first international standard for 3DCP construction, the ISO and the ASTM. And we wrote that, which was finished in May of 2022. You can just translate that.
Okay, if you can just speak little, so we can go into translate, so it's easier, so people understand better. Thank you. Nice to meet you. Okay, esta industria del robot realmente es una industria joven, no tiene mucho tiempo en el mercado y la gente la ha usado, pero la ha usado más como experimento. Vamos a iniciar a hacer casos, pero no de la manera que lo vamos a hacer, ¿no? Aquí el tema es hacerlo a grande escala, sobre todo, bueno, en los últimos años, que se ha estado trabajando en este robot que nosotros tenemos, que cumple con los estándares de construcción. O sea, muchos de los robots no tienen esos estándares de construcción con permisos, con toda la documentación que se necesita y se requiere para poder estar en el mercado.
So, yeah, so I was on the committee. We wrote the very first international standard for it, which has now been released. It's in the ISO, it's the International Standards Organization. It's also in ASTM, which is American Standards for Technology and Materials, and also in the DIN, which is the Deutsche Institut für Normen. So it's an international accepted 3DCP building standard. I was on the committee that wrote that standard. I actually wrote a lot of the standard internationally for this.
Él ha escrito lo que son los términos internacionales. Está el robot con los estándares necesarios para poder estar en el ramo de la construcción. Esto ha sido un trabajo desde mayo del año pasado de estar juntando toda la documentación, ahora sí, los requerimientos que se necesitan para estar a la vanguardia y sobre todo, bueno, estar, por ejemplo, para que opere en todo el mundo y que tenga toda esa logística, vamos a decir, desde permisos de cómo opere, en dónde, etcétera.
Okay. So the biggest problems were the standards and making sure that the way that things were being built was correct, that the concrete was correct, and just basically the building codes and all of that. The thing that we did, actually, it is now accepted in 42 countries. So if you're anywhere in South America, Europe, Africa, that's pretty sure it's pretty well accepted now. Okay.
Bueno, tenemos actualmente ya permisos para operar en 43 países y obviamente todo lo que es América Latina y varios países de Europa y demás están ya con toda la legislación necesaria para que pueda operar este robot en el mercado.
Yeah, when we started, there was almost no one interested in what we were doing. And when we finished, we had the standards organizations from 42 countries and over 200 different construction companies working with us. So it really pushed us forward, especially me. It really pushed me really forward, so everybody in the industry knew who I was and knew what I was doing, which was a really big plus for me and also for the company.
No, y al principio, bueno, nadie creía en nosotros, no les parecía como interesante el tema. Entonces, cuando empezamos a hacerlo, a demostrar de lo que es la capacidad, porque se han hecho las pruebas, se ha hecho toda vamos a decir, los ejercicios para ver qué funciona el robot, de cómo trabaja, y bueno, ellos mismos me han empujado a hacerlo porque ya hay mucha gente interesada, ya hay 43 países que lo están solicitando y a su vez, bueno, hay compañías constructoras que pues ya nos están buscando para poder trabajar con nosotros.
So now that we have all of that done, which was finished in May of last year, approved in June, and then it took 2 or 3 months to get finished, but it's on the ISO, it's on the ASTM, it's on the DIN. You can actually purchase it. If we work together, I'll actually give you a copy. You just don't tell anybody I gave you a copy because it's like 60 to 80 euros. Some of them are like 300 euros. So, but the point is now is the time when people can actually start building without a lot of complications that were there in the past. The biggest advantages of 3DCP, I mean, Camhirst is completely different. We have a lot more advantages than any other company, but the biggest advantages of 3DCP is you can build a very high quality in a very, very short time period. Like we can do 200 square meters in 48 hours. But you're talking about a building that is a lot better constructed, a lot better built than a standard building that's built with normal Portland concrete.
Okay. Bueno, y hace el año pasado, desde mayo a junio, ya tienen lo que es el ISO, que cumple pues todos los requerimientos para operar, ¿no? Y en esta parte es muy importante que tengamos la información, no le cuenten mucho a nadie, pero tenemos unos, los puntos necesarios para poder operar y sobre todo hacerlo de manera con dos cualidades o características muy importantes, que son tanto la rapidez como la calidad de nuestra construcción. Esas dos han sido pues nuestra cara número uno, ¿no? Que va a romper el mercado, que en 48 horas podemos tener una construcción y con toda la calidad.
Yeah. And just using 3DCP without the different innovations that we have, like the geopolymer, the Cam polymer and all of that, gives companies a huge, huge advantage. With geopolymer, and I'll go into that a little bit later, there's even more advantages. But just imagine a construction company that has like 6 or 9 people working for them. If they start using a 3DCP machine, then they can use the same amount of people that they used last year. But this year, they can probably build 5 to 10 times more houses in the same period of time using the same amount of people. That's huge.
Exacto. Y bueno, y tenemos aquí un ejemplo de que, bueno, operación, vamos a decir, con 6 o 7 personas que tengan para trabajar en construcción en una casa. Si lo hacen con esta herramienta del robot, pues obviamente la eficiencia que van a tener es grandísima, ¿no? En vez de construir esto en un periodo largo, estás hablando de 20 a 30 veces más rápido con la misma cantidad de personas y sobre todo con una excelente calidad.
And that gives any construction company, also investors, a huge advantage over almost anyone in the construction industry, because they just can't build at the speed that you can build with 3DCP. The problem with a lot of 3DCP companies is they have this huge gantry system, which has 4 feet on it. For each foot, for each leg, they cast a foot. One of the feet is like 2,800 pounds or kilos, 2,800 kilos. And so if they have only 4 of them, then you're looking at 12,000 kilos of cement feet that they have to cast. And they have to wait 28 days for them to dry, for them to cure. And then they have to take in these huge cranes and put the feet on there. So they're looking at 31 days before they can start printing. We have none of that. We can come in and start printing on the same day, within 3-4 hours.
Ok, y una de las, bueno, vamos a hablar un poco también del material que tenemos como el geopolímero, pero una de las cosas que tenemos como gran ventaja es que, bueno, la mayoría de los robots que existen en el mercado tienen 4, los postes, 4 que están con cemento. Sí. Piernas, que tienen mucho cemento, o sea, se lleva cemento, tienen que hacer perforación, o sea, como las zapatas, poner todo el armazón, necesitan los cráneos para poder mover todo el robot y se tardan casi 31 días en simplemente ensamblar el robot. Sí es rápido ya una vez ensamblado, pero 31 días se tarda en que se seca el cemento y está todo esto. En cambio, bueno, nuestro robot de 3DCP, hoy lo puedes armar y hoy mismo puedes empezar a construir. O sea, el de nosotros es rápido, es movible, sencillo.
Right.
It's just amazing.
So, and that gives us a huge advantage, because by the time they have set the legs and the feet and all of that and waited for it to dry 31 days. And started the first printing. By the time they started printing, we could have already built 10 houses. So that's a huge difference as far as our competitors in the 3DCP industry are concerned.
Y hablando pues de nuestros competidores, mientras ellos se tardan 31 días en armar el robot, nosotros en esos 31 días ya hicimos 10 casas. Entonces, obviamente es mucho más rentable, ¿no?
Yeah. A big advantage that we also have is using the different geopolymer concretes that we have, because they harden much faster. They harden in hours instead of in weeks. And the geopolymer just has so many more advantages. It's 95% more environmentally friendly. A house built out of geopolymer can last up to 10,000 years. A normal house is 80 to 100 years. I'll just let you translate that because there's a lot of technical information.
Ya. Y bueno, si ustedes ven el geopolímero, pues también tiene una ventaja adicional a lo que es el robot. ¿Por qué? Porque el tiempo de secado es muy rápido. Los otros materiales como el cemento tardan más en secar. Y este geopolímero, bueno, es 95% más ecológico y es más amigable con en el ambiente, ¿no? Además de que tiene muchas ventajas que vamos a ir hablando en este día.
Yeah, and it's and like I said, a normal house will last 80 to 100 years usually. If you put steel in concrete, then the steel rusts and then the house starts falling apart. We don't use steel, we use basalt, which is volcanic rock, just made into rebar. It's 82% lighter than steel, but you put it in concrete, it's 5 times stronger than steel. So using that in geopolymer, you can build a house that will last thousands of years instead of 80 to 100 years.
Una casa, bueno, normal tiene una vida de 80 a 100 años y obviamente aquí ya lo sabemos que esta casa podría durarte hasta 10,000 años, ¿ok? Una de las razones es porque no usamos lo que son las varillas, ¿no? Que eso es lo que hace que se corrosione. Entonces, aquí que se usa basalto, que es de piedra volcánica, entonces hace que sea más fuerte. Entonces no hay ese deterioro por el tiempo porque estos materiales pues son mucho más durables.
Did you say it's 82% lighter than steel?
82%, which is lighter, the
Basalt.
basalt?
Basalt, you can pick it up with your finger. I mean, it's 82% lighter than steel. So one ton of steel would be 280 kilos of basalt. That's incredible.
Okay, el basalto es 82% más liviano. O sea, dice, lo puedes agarrar con un dedo. O sea, es súper liviano. Entonces, esto también ayuda. They say, for example, here we make a question that is coming with this that you're talking. In the videos, it shows that they built and they didn't put even basalt. They only put like all the geopolymer. It is strong, or they don't need in the corners to put something?
It depends on the building. If you're only building one story, there are situations where you need no rebar. Rebar are the bars that are going in there out of steel, iron, or whatever. If you're only building one story, sometimes you don't need rebar. If you're building 2, 3, 4 stories, the higher you're building, the more support you're going to need. So it really depends on the building situation.
Pregunté, bueno, que está hablando de este tema del basalto y las varillas y demás, que por qué en los videos, en las esquinas, no vemos que ponen esos soportes. Entonces dice, bueno, eso depende de la construcción que se haga, ¿no? O sea, generalmente si es una casa sencilla de un solo piso, no lo requiere, pero obviamente si va a ser una casa que se le va a construir pisos arriba y demás, se tendría que hacer, ¿no? Pero depende la construcción.
I would personally suggest to put basalt rebar in any house that you build because it just makes it stronger. I mean, if you've got quite a bit of basalt in a geopolymer wall, you can drive a car into it and it's not going to do a lot of damage. It's incredible how strong this stuff is. It really, really is incredible.
que bueno, es increíble la forma en que si tú construyes con el geopolímero y el basalto, inclusive si tú vas y te estampas con un coche, el daño que ocurre en la pared es impresionante. Es un producto increíblemente fuerte, o sea, es impresionante la dureza que tiene el producto con esa sinergia, ¿no? Basalto con geopolímero.
Just for an example, NASA uses basalt and geopolymer in the space shuttle. And I actually worked on a group that worked with NASA. And NASA is going to be building houses on the moon and probably eventually Mars. And they will be using a 3DCP computer robot. And they will be building with geopolymer and basalt. So just for an example, and the military as well. I work with Megan Krieger. She's the head of construction for the military in the United States. She was on our committee and they use geopolymer and basalt. Okay.
De hecho, bueno, como dato adicional, la NASA trabaja con el material de geopolímero y basalto. Inclusive ya hay todo un proyecto donde se van a construir casas tanto en la Luna como en Marte, o sea, literal, con robots, y van a llevarse lo que es el basalto, y lo van a construir con basalto y geopolímero, ¿no? Por esa durabilidad. Y también en ciertos lugares de Estados Unidos de la parte militar, también utilizan estos productos ya por lo increíble que son, ¿no?
Yeah, if someone's interested, I can send them a direct link to NASA and a direct link to the Army Corps of Engineers or to oh God, the magazine, Adam, where the Corps of Engineers were in. She was listed at Forbes. She was listed in Forbes magazine for being for the top construction thing. And I actually worked with her on the project that she did there. She was in Forbes magazine with the things that they can actually look at the Corps of Engineers, actually look at Forbes magazine, actually look at NASA. They don't have to take my word for it. Go on to the real websites, look at it, and you'll see this is real. This is okay. If they want the link, I can send them the link.
You work with them?
I did. Yes, I worked with them in the past. Yes.
Okay.
Yeah. Not anymore. They're finished. They're finished now.
Okay. De hecho, bueno, él trabajó con ellos, o sea, tanto con la NASA y algunas de las cosas de basalto y de geopolímero con ellos, ya en el pasado, ahorita ya no, pero bueno, nos va a pasar por ahí unos links donde nos va a dirigir para que veamos en la NASA cómo utilizan el geopolímero y el basalto también en la zona militar, y también en Forbes hay varios artículos muy interesantes de esto. Yes, we want the link. Later you...
Okay. For the Army, it's the Army Corps of Engineers. Army Corps of Engineers does all of the building for the Navy, Air Force, Marines, Army, all of them.
Para toda la Armada Militar utilizan todo eso, ¿no? Lo que es la base naval y toda la parte de los castillos militares, donde está todo esto, ahí lo usan, o sea, para que las balas no pasen.
Yeah, okay. Okay. So there are a lot of uses for this. Also in airplanes, there's basalt and geopolymer in every airplane out there. So I
También en los aviones hay basalto y geopolímero.
Okay. And a lot of bridges now they're starting to use basalt instead of steel and iron, because with basalt, you don't have to worry about, especially if you're in a place where it rains. I know in South America, there's a lot of rainy areas. And if you have a lot of water, especially salt water, steel and iron, you build with steel and iron, you got 20 years and that stuff's falling apart. If you use basalt, basalt is volcanic rock. People ask me, how long will basalt last? And I say 4 or 5 million years probably. So there's no problem about that. And if you're building using geopolymer and basalt, you don't have to worry about salt. You don't have to worry about water. Geopolymer is 100% waterproof. It's fireproof. It's anti-allergenic. It's a completely different thing than cement.
Bueno, el geopolímero y el basalto, bueno, tienen las características de, por ejemplo, todo lo que haya lugares con mucha agua, por ejemplo, todo Sudamérica, como se erosiona lo que es la varilla o el concreto, bueno, obviamente esto le daría una vida, o las construcciones que se hagan con geopolímero y y basalto aquí en toda la parte, vamos a decir que esté pegada al mar, que haya lluvias, todo lo que es exceso de agua, bueno, pues le sirve muchísimo. Inclusive, la fuerza que va teniendo con el tiempo del basalto es muy interesante porque se puede construir a más tiempo, ¿no? O sea, estás construyendo algo para largo plazo, no para algo que se va a ir deteriorando rápidamente.
Okay, for people, I can send, we have a form, a document with all the information about geopolymer, about basalt, about 3DCP, and all of the links are on there. So we can send everyone that and they can look at that. And very importantly, there was a complete airport built in Australia, which is completely built out of geopolymer. And the university in Kingston, Queensland in Australia is the roof supports are completely built out of geopolymer. And now they're building all of their tunnels out of geopolymer because water does no damage. Heat does no damage to it. So Australia is realizing geopolymer is the way to go. And I think eventually the construction industry is going to have to go that way, mostly because of the environment, because of Portland cement, which I'll go into in a minute, but go ahead.
Bueno, de hecho que bueno, nos van a pasar por ahí más información técnica, por escrito, y también, bueno, es importante que tengamos, claro, bueno, que esto de hacer poco corrosivo, pues, muchos países lo utilizan, ¿no? Como por ejemplo Australia, ya tiene pues su aeropuerto y muchas cosas, y con el tiempo el geopolímero pues se va a posicionar más en el mercado, que el mismo cemento, ¿no? ¿Por qué? Pues precisamente porque es un producto ecológico y que pues da mucho más durabilidad y muchas ventajas.
Okay, this is the airport that was built that he's going through here. The old guy there, he'd hate me if I said that, is Joseph Davidovich. He is the inventor of geopolymer. We work directly with him. And he invented geopolymer in 1976. If you go up a little bit, here's the university in Queensland, which this roofing beam on the right-hand side is completely made out of geopolymer.
Bueno, nosotros trabajamos con esta compañía y todo esta que están viendo en Australia es el aeropuerto. Todo esto se construyó con geopolímero.
Okay, can you go up some more, Adam? And in here, there's also the airport, which is completely, here it is right here, Wellcamp Airport is completely, they used 100,000 tons of geopolymer. It's the whole airport, runways, everything is completely built out of geopolymer.
Aquí 100,000 toneladas se utilizaron para construir este aeropuerto con geopolímero. A question, the floor and the ceiling can be made with geopolymer, not with the rock, but with the material. Yes.
Yes. Yeah. The good thing about geopolymer, and the thing that Joseph Davidovich said, he said, the great thing about geopolymer is not only that it'll last for thousands of years, that it's waterproof, fireproof, that it's cheaper, that it's 95% more environmentally friendly. If a plane was taking off in New York City and they were doing the runway in California out of geopolymer, by the time the plane got to California, the plane could land. That's how fast it dries. 3-4 hours, it's completely hard. That's unbelievable.
Bueno, la pregunta, le pregunté que, bueno, por ejemplo, sabemos que el robot no construye el piso ni el techo, ¿no? Pero sí se podría hacer de geopolímero ese material. De hecho, por eso lo están utilizando en el aeropuerto como piso, porque tiene un secado rapidísimo, o sea, lo pones y luego está seco, obviamente con todas las características que ya sabemos, ¿no? Que es 90% más ecológico, que es antiinflamable, es hipoalergénico, térmico, etcétera. O sea, tiene todas las características adicionales, pero en realidad, por ejemplo, para pista de aterrizaje y demás, pues es mucho más fuerte y obviamente es más potencial para todos esos usos, ¿no?
Yeah. here you can see the tunnels. They're building tunnels there. They're going to start building highways. Because the highways get torn up by trucks and everything. And if you're building out of geopolymer, you have a completely different thing there. My joke about geopolymer always is, if you have a house out of geopolymer and you have a fire in the kitchen, just close the door. I don't say close the door and order a pizza and watch a movie, call the fire department. But the thing is, if you have a fire, we have a video that's on YouTube, which we can let everyone see. The fire cannot get through the wall. A normal house fire will be about 800-900 degrees Celsius. Geopolymer will take over 3,000. So if you have a fire in the house, close the door, call the fire department. It can't get out of that room.
Ok, y dice, bueno, de hecho se van a hacer hasta carreteras ya con este producto, y al ser, bueno, hay un video por ahí que hacemos como prueba dentro de los estándares que se tienen que cubrir de incendio. Entonces, por ejemplo, dice, si empieza en una casa el incendio, en una recámara, bueno, pues se cierra la recámara, dice, tampoco es como que para que hables a una pizza y te la comas ahí, ¿no? Que te tardes en hablarle a los bomberos, pero se contiene el fuego. Y obviamente en una construcción normal, pues no es posible esto, ¿no? Entonces es realmente ya probado de que es contra incendios.
Actually, in the video, it's a very early video, and it was using a type of aircrete, which is a concrete with millions of little bitty bubbles in there. We burned the whole house down with the fire department there. It was 800-900 degrees Celsius. I don't know what that is, Fahrenheit. But it was 800 or 900 degrees Celsius, the fire, and the fire was here, and the wall, you could put your hand on the wall was 42 degrees, and in the room it was 35 degrees, and on the other side of the wall it was 900 degrees.
Bueno, habla de la cantidad del calor que puede haber en el incendio, que por dentro la tocas está a más grados, por fuera está totalmente, o sea, vamos a decir no frío, pero en muchísimo menos grados.
Okay. There are so many advantages to this. It would take forever to go into everything. The main thing is, me and my team, we've put together the 3DCP, which I've been working on for over almost 6 years now. The basalt, the geopolymer. So we have eco-friendly, it's 95% more eco-friendly than Portland cement. We have houses that will last for thousands of years. We have houses where the construction is much, much better than a normal Portland cement house, and like fire, water, and all of that. You're just getting a lot better house. And because we can build so fast, it's cheaper. It's much, much cheaper. And that's the huge, huge advantage, is to get a cheaper house that's actually much better than any other house and lasts much longer because of all the different technologies that we're putting into this.
Bueno, nosotros, como ustedes pueden ver, tenemos tanto la tecnología del robot como la tecnología del geopolímero, del basalto, que esto sumado, pues obviamente da un ahorro pues muy rápido, ¿no? Muy interesante. ¿Por qué? Porque todo en esa sinergia, o sea, tanto tener un producto de calidad con la rapidez del robot y demás, hace que nuestras casas pues realmente estén por encima de lo que hay en el mercado. O sea, nuestras casas van a ser mucho mejor que cualquier construcción que ya está actualmente realizada.
Okay. The probably most interesting things about anyone interested in investing or getting into this business is thinking about, let's say you had on a normal work site for cement and everything, you're working with the cement and all of that. You're looking at about 9 workers working about 5 days to finish the work that they're doing on that. And if we were to do the same building, you're looking at 3 workers working 2 days. So just the amount of people and the amount of time, you save money because you're using less people and you are spending less time. But additionally, that means you can be building another house while the other team of the 9 people is still building the first house. So you can be building 2 or 3 houses with 3 people in the same time that the 9 people are only building 1 house. Okay.
Bueno, aquí el ahorro es muy claro. ¿Por qué? Porque tenemos que el robot necesita 3 personas para operar, ¿no? Entonces, vamos a decir que si en una empresa se va a tardar X tiempo en hacer una casa, acá en 48, 72 horas está haciendo una casa con 3 empleados, y vamos a decir que si del otro lado están otros 8 personas, pues esas 8 personas, y también están utilizando el robot y también están trabajando, pues estamos hablando de que se pueden construir mucho más casas. Entonces, además de ser más rápido a mejor costo, en la rapidez pues tienes mucho más ganancias porque puedes construir más rápido.
Yeah. So, I mean, the thing is, people look at it and they say, oh, so you can build faster, so you can build a house. You know, one team is finished faster than the other, than the team using conventional construction. But it's not only that. It's very important that the people understand while they're still on this house, you're on the second and the third. So it's not only the speed, it's the amount of houses that you can build. So you're looking at maybe building 5, 10 times more houses, the construction company, than they built the year before. That's the big thing. That's what's really buzz everyone away. And it's costing you less money per house. That's incredible.
Entonces, aquí lo que se tiene que tener claro que no nada más es la rapidez, ¿no? Sino es la rapidez sumada con la cantidad de casas que se pueden construir. O sea, no es lo mismo construir una casa en determinado tiempo, sino estar construyendo más casas y obviamente a un costo más bajo y además escalable, ¿no? O sea, que vas a tener pues grandes utilidades.
Yeah. I mean, there's, like I said, there's so much to go into, just all the things about basalt, all the things about geopolymer. They've proved now that I think it's called Pumapunku in South America.
You know, some of the questions that they want to know, it's about how the robots construct, how it's built,
okay.
The house.
Okay, just one
there
thing.
There are videos.
No, just one second. There's a very, very, very old city in South America. I'm pretty sure it's called Pumapunku. And Joseph Davidovich and some researchers went there and looked at the stones because they couldn't figure out how they cut the stones thousands of years ago, because they had no metal, they had no steel. And they figured out that they used geopolymer. They didn't cut the stones at all. They cast the stones in forms, which is very, very interesting. I think for anybody to understand, because these buildings have been around for thousands of years and they're still there. And they were not carved in stone, you know, like they normally carve. They were actually cast geopolymer.
Claro, y una de las partes importantes, por ejemplo, del geopolímero, pues es como la resistencia, porque es como las piedras, ¿no? Si ustedes ven alguna de las antigüedades de lo que se construyó en América con piedras, bueno, actualmente vas y sigue existiendo. O sea, ha pasado cuántos años, miles de años, y sigue ahí construido. Entonces, esa es la dureza que tiene nuestro producto.
Okay, one last thing, and then I'll go into questions. With normal concrete, if you're going to drill a hole into the wall, you have to put like the rubber fitting thing in there, and then you can screw the screw in. With geopolymer, it's like granite or marble. You can just screw the screw straight into the wall. And the longer the building is there, the harder it gets. Actually, granite and marble would be categorized as a type of geopolymer. A geopolymer is nothing more than different substances coming together and having a reaction to where they form almost like a rock. So it actually is a rock. Okay, that's basically.
Okay, por ejemplo, cuando ponemos un cuadro, no sé qué, se hace el hoyo y ves que se pone el taquete y pones luego el clavo. Bueno, aquí en la construcción tradicional, aquí no es necesario, es como el mármol. Que es, o sea, y el mármol se puede considerar como un geopolímero, es tan fuerte y entonces nada más es una perforación y entra el clavo, ¿no? Pero además de eso, con el paso del tiempo se va como añadiendo, entonces se hace más fuerte lo que se mantiene, digamos, se afirma el clavo en la pared.
Okay, the questions you got.
about the robots, how it works, like how it works different from other robots.
Okay.
We know that it's a different part. The first part that you say 4 legs, but the other things they do
yeah, no problem, no problem. Like I said, a lot of the robots, I would say most of the robots have a gantry system, which is 4 legs coming down with the cement feet, and all of that, which is huge because it's outside of the house. So it's built outside of the house, and then they can build the inside of the house, which means if you're going to build very high buildings, you can't do it with this system. Because once you get above 3-4 floors, the wind blows and it just starts moving around. So it's totally impossible to do that. The other systems are like a robot arm that just, like in the automobile industry, that just goes in and builds it. The problem with that is the arm is very, very short. You're looking at a maximum of 6 to 9 meters. So you have to keep moving the robot. Apis Core, I love the people at Apis Core. I work with them in the committee. I know them very well. But when they built the building in Dubai, I think they moved the robot 280 times. And it weighs like 3.5 tons. It's not like go in there and move the robot, it's like bring in machinery and move it. And our system is a Cartesian system, which means it only has 2 legs and it's on tracks. And the tracks are very simple, so you can keep adding to the tracks. The first robot we did had a robot arm, and it had like a track on it, like a tank. The problem is it weighed 2.5 tons. So if you're in the 2nd, 3rd floor, the robot has too much weight. So it's very difficult to find a floor that will hold the robot. It just goes through the floor. I'll stop there and go ahead.
Okay. Bueno, una de las cosas que nos hace también diferentes el robot es que en una construcción, vamos a decir que se pone el robot con un solo brazo, entonces el brazo no es muy largo, entonces tiene muchas limitantes. Entonces, si está haciendo una construcción, pues tienen que estarlo moviendo muchas veces, ¿no? De hecho, en una de las construcciones en Dubái se tuvo que estar moviendo el robot para poder construir más. Y la forma en que opera es más complicado desde que no alcanza a hacer más cosas de altura. Entonces, en este caso, el de nosotros es nada más 2 postes, y en esos 2 postes están los rieles que se pueden ir adjuntando más y se pueden mover mucho más fácil y se puede escalar, ¿no? Hacia otros pisos y tiene más altura, etcétera.
Okay, the robot arms was the 2nd robot that we had. And
Ellos también tuvieron un robot.
The problem with that is the track on the bottom of it, you have to buy from, it's ABB or KUKA were the robots we were using. And the track cost 30,000 euro for 6 meters.
Wow, expensive.
But it wasn't worth it. So, and we have a track, you can, for 30,000 euro, wow, I don't know, you could do 150 meters probably of track, because we have just a very, very small track that just runs along the bottom. So we've developed, the first robot we had was 2.7 tons. The second was about 1.7, 1.8 tons. The one we have now is 480 kilos. So it's very, very small. It's very light. It's very flexible. And you don't have this huge weight, and you don't have the problems of having to build outside of the house.
Bueno, ellos también construyeron un robot o sea, antes de este robot, uno de un solo brazo, pero era pues ahora muy caro construir, inclusive, no sé, 15 metros estaba más o menos un costo de $30,000, o sea, era no negocio, no era nada de negocio. Entonces, este robot pues es mucho más liviano, flexible. Entonces, obviamente con esa flexibilidad y esta rapidez, pues puede trabajar mucho mejor ahorita.
Yeah. The one we have now it has 2 legs, and then it has the bar across the top, which you can change the width of it depending on what you're building. So you have the 2 legs, and you can change the length of the arm on the top for whatever you're building. And it's just put on tracks for however long you need for building whatever the length of wall or walls, because you can be 12 meters, 20 meters. So you can build different walls on the inside, but it's much more flexible. It's much lighter. It's much easier and faster to move. And that gives us a lot of advantages. And we can build from outside of the house or from inside of the house. That's very, very important.
Ok, esto tiene, el robot de nosotros tiene dos líneas y se pueden mover, lo puedes hacer más ancho o más delgado. Entonces eso también es una parte muy importante. Y también puedes poner los rieles hacia afuera o hacia adentro, ¿no? Y algo que se tiene que destacar es que este robot puedes construir tanto paredes externas como paredes internas.
That's basically the main thing about it. Is the big thing is that we use geopolymer. We can use Portland cement, but we use geopolymer, and our robot is much lighter, much more flexible, and our setup time is just a few hours instead of weeks. That's the most important thing. It's the speed. It's all about getting a very lightweight robot that's very, very flexible, can do a lot of things, and not having to spend a lot of time setting everything up.
Y bueno, esto al ser liviano, ser flexible y demás, pues hace que tú lo puedas mover rápidamente de un lugar a otro, y esto pues es más productivo. Obviamente pues va a darte mejor resultados porque no lo vas a tardar en mover y lo puedes luego usar. Esto pues es diferente en el mercado.
Our main goal, most of I refer back to Henry Ford. I'll just tell you real short. In 1900, there were 5,000 automobiles built in America. 5,000 in 1900. From 1907 to 1923, I think, Henry Ford built 15 million automobiles. That's us. We're looking to do mass production. We're looking to do thousands and thousands and thousands of robots out there, so that there can be a lot of houses built. So we built a robot that's very flexible. The quality is higher than anybody out there, but it's the mass production thing. And I think it's important that people understand a little bit. I'm sure they know who Henry Ford is, but 5,000 cars in 1900, and Henry Ford built 15 million in about 5 or 6 years after that. That's what we want to do, is go into the mass production.
Okay, y la misión que tiene que tienen ellos es, vamos a decir, como Henry Ford, que hizo los carros de Ford. En los primeros años hicieron nada más 5,000 coches, ¿no? Y ahora, bueno, ustedes saben que hacen más de 15 millones de coches, o sea, han hecho millones y millones de coches. Entonces, precisamente eso es lo que Camhirst quiere hacer, ser una compañía que va a producir miles de robots y se van a repartir en todo el mundo. ¿Por qué? Porque tenemos la mejor calidad. Estamos por encima de calidad dentro del material, o sea, con todo el combo de tanto material, basalto, geopolímero, robot, hacemos la diferencia.
The thing is, in the early stages of the car, I go back to the cars, only the rich people could afford the cars. At the moment, only huge multi-million, multi-billion-dollar companies are using these robots. We want to make these robots available for anybody out there. That's what Henry Ford did. Henry Ford made it so everybody could. The reason you have a car is because Henry Ford built for everybody, and that's what we're doing.
Porque, por ejemplo, Henry Ford hizo carros para todo mundo, ¿no? Para las masas. Él no pensó solamente en el sector de los millonarios, y eso es lo que también Camhirst está buscando, que estos robots no solamente para el sector millonario, ¿no? Porque ahora nada más constructoras de mucho dinero pueden tener esto. Pero ¿qué va a hacer? Ellos lo van a hacer de una manera distinta, donde mucha gente va a poder acceder a los robots. Inclusive hoy, por ejemplo, tú tienes un coche porque Henry Ford fue el que hizo esa disrupción de vamos a tener coches para todos. Entonces nosotros queremos ser esa compañía en la construcción donde va a poder dar a cualquier constructora estos robots de la mejor calidad.
Sí.
Just I want to add to that very quickly. So, Ali, look, the important thing is it's about timing. Okay, these amazing people who have taken their time and come on the Zoom today, you know, they're different compared to most of the people. You know, they have what I call an entrepreneur mindset. They are people who want to make a difference to their life and the lives of others. So first of all, you know, tell them, you know, we appreciate them, that they've taken their valuable time and come on the Zoom today to learn more about the Camhirst opportunity and how this technology is going to change the world. So if you share that with them first, please.
Que bueno, que primero que nada, gracias a todos ustedes que estuvieron en la sala, que se den el tiempo de conocer más, un poco más de la información que se está dando. Y bueno, estamos aquí listos para ayudar.
Knowledge is power, Ali. So if you learn about something which could make you money, make you a lot of money or make you life-changing amount of money, that will not happen unless you take action. So what you've seen today, or what we've shared with you today, is to say to you, you're in the right place at the right time. If they take action and connect with construction companies, if they will sell robots and they'll make a lot of money. So if you explain that first, please.
Y bueno, esto se trata también de mentalidad, ¿no? Que estamos en el timing, en el tiempo correcto. Que esto tenemos ahorita, pues, la información correcta y tenemos todo para iniciar este negocio y arrancarlo. Y hoy están ustedes aquí porque ven una opción para hacer un negocio y crecer de una manera grande.
We have something that every government can benefit from. We have something that every construction company can benefit. We have something that even your local construction builders can benefit from.
So
Tenemos
two people have raised their hand. When you're finished, we need to see
Tomorrow we have the question and answer session, so Ali will be able to collect their questions, and perhaps they can also ask questions tomorrow. Sorry, go ahead.
Yeah, we have the questions and we are going to make it direct.
Super.
Sorry, well, I forgot what you were explaining.
Governments can benefit, construction companies can benefit. We made it affordable.
Okay.
That's what Ed was saying. The Henry Ford example, we made this available for everyone.
Esto, bueno, se benefician empresas de construcción, se benefician gobiernos, y esto es para todos, ¿no? O sea, cualquiera va a poder tener esto como Henry Ford, vamos a poder tener robots en cualquier parte del mundo.
They sell one robot with training, they make $13,750.
Si esa es la venta de un robot, o sea, bueno, la venta de un robot que tiene un costo de $275,000.
I just received an order for 10 robots. The gentleman who's introduced that order, that customer, he's going to make over $130,000.
When 100, the amount, what is?
So what it is, I'm saying one person with the order I have received recently is for 10 robots. So the person who's introduced that customer is going to make $13,750 per robot. That's over $130,000 for one sale of 10 robots.
Okay. Bueno, como ven, tengo ahorita una persona que hizo una venta de 10 robots. Nada más de esa venta de 10 robots, él por esa venta se está llevando un 5%, ¿no? O sea que estamos hablando como de $100,000 aproximadamente.
So that could be them. All we need to do is work together, all of us together. We share the information with you. They need to just share the information on social media. They can contact construction companies. But what's even simpler than that, Ali, is the opportunity for people to become founders. Because here, once you buy one founder position, and these are going to go very, very soon, one founder position of $1,000 gives them lifetime profit share via the private club.
Y bueno, y esto es simplemente pues compartir, ¿no? El que tú compartas algo vas a tener ese beneficio, pero no se olviden que aquí lo más interesante, porque está por acabarse, ya se va a terminar las membresías de fundador, así que bueno, es importante que la gente tenga una acción, ¿no? Que tenga un porcentaje trimestral de las utilidades de la compañía, así que ya están por acabarse las membresías, así que quien tenga todavía esa intención, que no se quede la intención y que lo ejecutemos.
And what's really important here, Ali, is that that the founders, being a founder is very, very important and it will be beneficial. But they can also, remember, with a if you are a founder, you'll make money from referring people as well. So being a founder is important, but you must be a founder to earn obviously affiliate commissions for introducing others, because we want to reward people for creating awareness.
Y queremos recompensar a las personas con su recomendación. Entonces, si tú recomiendas este negocio, por ejemplo, el de fundador, pues tú también tienes un porcentaje de utilidad, ¿no? Tú vas a ganar un porcentaje de esas recomendaciones.
We want to change people's lives. Even if somebody has no money, you can be a free member, sell a robot, make over $13,000. Again, the robot leasing plan, you could be a free member and introduce somebody and make money. But the founders, because it's a very exclusive club, you must be a founder to be able to earn money from the affiliate program.
Es muy importante, bueno, que tengamos la opción de que podemos también duplicar nuestro dinero en el leasing plan y ser parte de él, ¿no? Y por otro lado, bueno, para ser fundador y que tú puedas recibir ganancias de las recomendaciones, es importante que pues tú también tengas tu membresía.
And one of the important things about the robot leasing plan, we could have easily got the money from venture capitalists straight away, but we decided we want to give ordinary people a chance to fund the robots at this initial stage. So this is amazing. This is like if everybody on the call put money into buying a house, we then buy a house for $200,000. When we sell that house for $250,000, we are sharing the profit. Everybody will know of people who buy and sell houses and make money. But this is even better. We're buying robots. We already have orders for robots, and we are sharing the money with the people who are putting money into this together, and also with the company. So this is a very, very easy way to make money by putting money in. And still, there's a few days left for June. Instead of 9 months, the participants' money doubling in the robot leasing plan, right now, if they join before the end of this month, whatever they put in, if they put 1,000, it becomes 2,000. It's daily rewards. If they put 5,000, it becomes 10,000 within 6 months. This is a great opportunity that they can be part of something amazing and make money without even introducing anybody.
Y bueno, es ver desde todo el plan que él podría traer un inversor grande, 2 o 3, pero bueno, la idea no es traer solamente un inversor, sino hacerlo compartido y que todos podamos beneficiarnos. Es como si entre todos compráramos una casa, o sea, cada quien en un pool, se compra la casa, se vende la casa y se tienen utilidades. Pero aquí no estamos hablando de una casa, estamos hablando de robots. Así que esta parte de leasing, aprovecharla, porque bueno, saben que la promoción del mes de junio fue duplicar en 6 meses. Ya estamos en los últimos días para que se termine el mes, así que bueno, generalmente son 9 meses, este mes está a 6 meses para duplicar tu dinero, así que aprovechar esta oportunidad.
So one of the last things I want to say is this is all about empowering people, creating prosperity, changing lives. Not only can we change everybody's lives that are on the call today, but they can also change the lives of others as well. So being part of Camhirst is about creating a better world through kindness and technology.
Ser parte de Camhirst es ser una mejor compañía donde quiere, pues no nada más hacer gente que sea un negocio normal, ¿no? Sino que realmente nos cambie la vida y esa es la misión de Camhirst, que pueda tocar a muchos lugares, que nosotros mismos vamos a compartir y vamos a hacer el vehículo para cambiar muchas vidas y vamos a hacer el cambio a través de la robótica y la tecnología.
So we are going to become one of the biggest companies in the world. Those who are part of it right now as early adopters, this is going to be life-changing for them. Those people who get involved are the ones who are going to benefit the most, and those who don't get involved are going to see others benefit. So we hope all of you can see why this is an amazing company. We have Ed and his team, one of the best specialists in this space. We have a great marketing team, and we are focused on making this one of the biggest companies and changing lives. So I'm not going to say much more now because we've been on the call for 1 hour, 15 minutes. We'd be delighted to have everybody back on the call tomorrow. It's a different link. Get back to whoever's invited you. They'll answer your questions. If they can't, they'll put you into touch with Ali. If Ali can't, they'll put you in touch with me. Whatever we can do, we're here to help you understand this project and help you profit from this. Thank you so much, Ali.
Y bueno, queremos realmente impactar en el mercado y ser una compañía que marca la diferencia. Somos pioneros, tenemos hoy la oportunidad de iniciar en esta gran oportunidad, así que bueno, a tomar ventaja a todos los que estén aquí. Agradecerles que estuvieron en este Zoom. Mañana va a haber una segunda sesión, ya que hoy ya fue un Zoom de 1 hora 15 minutos. Más tarde les pasamos el horario y la sala en la cual sería el día de mañana. Quien tenga las preguntas, por favor, hágame llegar las preguntas para mañana estén las preguntas aquí listas para responder. Así que bueno, muchísimas gracias a todos, que tengan una excelente tarde y cuídense mucho. Hasta la vista. Bye bye. Thank you, Adam. Thank you, Ed. See you tomorrow.
Thank you. Gracias. Todo.
Thank you.
Bye.
Bye, everyone. Bye.
Bye.